Hello everyone, this is Mr. Clement here, and I am going to do the feedback video for the automated quiz on the rules of differentiation. So without any further ado, let's get started with that. Number one asks you to find f prime of 2 given this f of x. So you should recognize that this is a chain rule, and therefore my derivative f prime of x is going to be 4 2x squared minus 7 to the third multiplied by the derivative of the inside, which is 4x. Now I'm asked to find f prime of 2, so I'm going to do f prime of 2 equals 4, 8 minus 7 to the third times 4 times 2. So that's 1, that's 16, that's going to give me 32. Now notice what I've done here. I didn't take this guy and simplify it. So I didn't put the 16 in the 16 and write f prime of x equals 4x, 16x multiplied by that. And the reason is it's an unnecessary step because I'm asked to find this value. I'm not asked to find the derivative. So you're just writing an extra step and doing a calculation which can be done in this step here. So the 4 and the 4 I can put together when I substitute. I don't need to do it beforehand and write an extra step. So think about that when you're taking the derivative. If you're asked to find the value of the derivative at a certain point, then don't worry about readjusting the function. Just leave it the way it is and substitute right away. Now, most of you probably did this without a calculator, but I want to show you how to do this with your calculator because on a calculator section, sometimes they'll ask you to find a derivative, and people just spend all this time trying to get a derivative, and they're not worried about whether you can find the derivative. They want to know whether you can use your calculator, and they made the derivative really, really hard, and it's going to be really difficult to do. So this first one, that's under math, the derivative. There it is, 8. And then when this comes up, it's d dx, and we need another set of parentheses. 2x squared minus 7, close parentheses, all raised to the 4th. And then I want to evaluate this at x equals 2. And then I can hit enter, and there's the answer, 32. Now, you need to remember that the process that your calculator does, I'm pretty sure it's some sort of loop that's doing. Those who do computer programming will understand that. And it just keeps putting the previous answer back in the loop. And then it takes the first answer and minuses the second answer. No, second answer minus the first answer. And when that difference between those two get really, really small, then it'll come out of the loop and give the answer. Right, so sometimes they're not going to be exact answers that we would get algebraically. You just have to realize that it's the limitation of the calculator and the program that's using to calculate it. Okay. Now, if you're using the TI Inspire, it's the same notation. I forgot where that is located, but it might be under algebra, and then you can find the nth derivative, and you're going to type it in exactly the way that you see it. I think since the TI Inspire is a little more powerful than this, you're going to get more functions that turn out to be exact versus the TI 84. All right, so let's move on to question number 2. And question number 2, hopefully you could see, is a product rule and a chain rule. Right? Now, what you might want to do, everyone, when you're doing these things is to, and I think I mentioned this in one of the live lessons, that you should go through all the problems in the textbook and just read through them and say, oh, that's a product rule, and inside the product rule is a chain rule, right? And just keep going through and doing that and identifying what rules you have and how many you have. And then every once in a while, you actually solve a problem. So here, I could see I have a product rule. And here is my chain rule. So what might be helpful is if I rewrite this so my chain rule is going to be a little bit easier to do. So g of x is going to equal x 2x minus 1 to the half. So therefore g prime of x is equal to 1 multiplied by 2x minus 1 to the half plus x times 1/2. 2x minus 1 to the negative 1/2 times 2. Now again, I'm asked to find this value here, g prime of 1, so I'm not going to do anything with this guy. I'm going to automatically substitute it in. So when I do substitute that in, g prime of 1 is going to equal 1 to the half is times 1 plus, if I wanted to, I could do this just because that's really easy to see. I can cross those guys off, and that's going to give me 1 times 1 to the negative half, which is 1, and therefore I'm going to get an answer of 2, and there's my answer. Okay, so we could go back to the calculator. I'll do one more on the calculator and show again math 8. We're going to do x, and then this was what? X second root 2x minus 1. I'm going to come out and I want to evaluate that at x equals 1. And there's my answer 2. Okay, so even in the book, if it says no calculator section or something like that, every once in a while take out your calculator and practice this so that you see how this is done, and it just becomes really, really easy. And then if it shows up on a calculator section, then use it if you want, right? Don't spend time taking the derivative, right? In most cases, they're asking you whether you can use your calculator or use some sort of technology to find the derivative. Okay, question number 3. All right, what I see here is a quotient rule. So the whole thing's a quotient rule, and I have a chain rule in it. No, there's no chain rule, just a quotient rule. So the quotient rule says that dy dx is going to equal. Now I'm going to write it out differently here, just as an option. Those who want who want to make sure they don't miss anything, you can do this to start off till you feel comfortable. And I like writing something like this: 2x minus 3 prime. I'm just going to write out the quotient rule with the functions I have, and then so I'm following the formula exactly the way it's written, u prime v minus v prime u over v squared. So I'm just going to do that, right? Now for these simpler ones, I hope you don't have to do that, but some people like this for a few times, but you do want to get out of that habit and not have to write this, especially on these simpler ones here. This is helpful if there's like a two chain rules inside of a quotient rule, then this is sometimes helpful to make sure that you don't miss anything, right? So this is going to be 2 4x squared minus 1 minus 2x minus 3 times, 8x, all over 4x squared minus 1 squared. Now again, I'm asked to find the value at x equals 0, so I'm not going to do anything with this derivative. I'm going to substitute right here, and when I do that, that's going to equal 2 times negative 1 minus 0, right? Because I'm going to have negative 3 times 0 all over negative 1 squared. And that's going to give me negative 2 as the value of the derivative. So it might be a good idea here that you write what you're doing here at this point, because these guys aren't equal, right? You want to change that up a little bit. So you might want to put dy dx evaluated at x equals 0, or you could say y prime of 0, anything like that. You want to be careful there, because remember, I doubt IB would do anything with this thing, but they're really sticklers with notation sometimes, and these two things are not equal, and when they're written that way, they appear to be, right? So, again, and also on the mark scheme, this would be a method mark, right? M1. So if you missed the derivative, but you did write this down, that you actually substituted the 0, then you would get the M1, but the A0. All right, I'm not going to do that one on the calculator. You can practice that one. Just remember that to get your fraction to type it in, then you're going to hit alpha y equals, and then you can bring up the fraction. You can bring that up inside the derivative like you would on the regular screen. So you might want to practice that afterwards. Okay, number 4. So here I notice that I have a product rule and I have a chain rule inside it. So if I'm going to find f prime of x, right, then I'll do this one out a little bit. I think I'm going to need a little more room here. So so here's f prime of x, and I'm going to take the derivative of the first multiplied by the second plus the first multiplied by the second, right? So I would do something like that. And then I won't miss my chain rule here, because sometimes if there's a chain rule inside of a chain rule, you only do one of them in this case, right? And this is a nice way not to miss a rule. Again, this one wasn't too bad. So that's 2e to the 2x sine x plus e to the 2x cosine x. So if I factor out an e to the 2x, I'm going to get 2 sine x plus cosine x. So therefore, it looks like the answer is going to be B. All right? I'm not going to bother switching that around. It's just a waste of time. I doubt IB will have a multiple choice like this. But maybe it'll say on the quiz, show that. So it says show that the derivative of that is this function, right? Then I think you can stop here, because it's obvious that the next step is going to be, you just swap them around, right? They wouldn't have a multiple choice, they'll have a show that. And remember that when they have a show that, you can't use the answer. I can't use that derivative that they've given me. I must get to that answer. So notice I didn't use that answer. I got to the answer, and I got the answer that they wanted. Okay, they probably not going to have a multiple choice like this. Okay, so number 4, we want to find that derivative. So again, I'm going to identify my rules. I got a chain rule inside of a quotient rule. So again, if you want, f prime of x is equal to the derivative of this, ln of the cosine of x, times the cosine of x, minus ln of the cosine of x, times the derivative of the cosine of x. All right, all over cosine squared x. Now at this point I would stop, because and take a look at my answers, right? Because I always like to know where I'm going, and I would see this, 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 and this. So I got to keep going because they're all the same, right? But if 2 of them were cosine of x, then I would just pick the one with the cosine squared of x and not have to go any further. Actually, the cosine might cancel out, so you'd have to be careful of that one. That might not be a good idea. So now that derivative is a chain rule, so it's 1 over the cosine of x multiplied by negative sine x, the derivative of cosine of x, multiplied by the cosine of x, minus ln of the cosine of x, multiplied by negative sine x, all over cosine squared x. And the cosine's going to cancel, so that's going to give me negative sine and a plus sign. So I'm going to take out the sine of x, and that's going to give me negative 1 plus ln of the cosine of x over cosine squared x. Okay, and that looks like it's going to be C. Now here's a little tip for you if you have some time on the exam and you're going back and looking at your answers, right? If you're unsure of this answer, then check it with your calculator. So what I'm going to do is I'm going to let my calculator find the value of the derivative at a point, and then I'm going to check it in my derivative. So what do I mean by that? I am going to take math 8 of ln of the cosine of x, that's x, oops, alpha y equals, I'm going to bring up my fraction, that's the ln of the cosine of x. Now it doesn't matter if I'm in radians or degrees. It will when I put in my value. I have to make sure that I put in the correct value, right? And since my calculator is in radians, I'm going to use radians. So that's ln of the cosine of x, parentheses, over cosine of x. And I'm going to evaluate this at pi over 4. Now, I'm not going to use 0. I'm not going to use pi or pi over 2 because those guys, the sine could be 0, the cosine could be 0, and then it's going to blow up if there's something in the denominator that's 0, right? Or it could give me an answer of 0, and that's really not going to be too helpful. So a good choice might be pi over 4. So I'm going to do pi over 4. Enter. So that's a -1. Now, what I'm going to do is actually check the derivative I got using pi over 4. So that's going to be alpha y equals, and it's the sine of pi over 4. And then it was parentheses the ln of the cosine of pi over 4. The ln of the cosine of alpha y equals pi over 4. Minus 1. Oops. I got to do minus 1 inside there. Minus 1. Like that. Oh, I need a parentheses at the end here. So I'm going to insert a parentheses. There we go. Yeah, that's what it was. And then it's going to be parentheses cosine of pi over 4. I hope I typed this in right and I remember it from my thing. Parentheses squared. Now if I hit enter, I should end up with the same, there it is, right? Now notice I got the same all the way up to 5 decimal places, and then it's different. I have to assume that I got the right answer there, and remember that when you take the derivative using this built-in function, it's not the same method as what's doing here. So you might have slightly different answers, but I'm pretty confident that I got my derivative correct. Now remember, you can do this on a non-calculator section. It takes a little bit longer when I'm doing it on the computer like this, but if I'm typing it in on the screen, it doesn't take that long at all. And if you're worried about it, then just check it off when you're taking the test or the exam and come back to it after and say, I'll check that one using this method when I'm done the test if I have time, right? So a good little trick there to check your work for derivative even by finding the value of the derivative and checking it against your actual derivative. All right, number 6, this again, we just have to recognize the rules. I got a product rule and a chain rule. So this is a product rule overall. And right here is going to be a chain rule. All right, so when I take the derivative, dy dx is going to equal 2p of x times p of x prime, prime, times m of x plus p of x squared times m prime of x. So y prime of 1 is 2, p of 1 is 1, p prime of 1 is 2, and m of 1 is -3. Plus p of 1 is 1, squared is 1, m prime of 1 is -3. Sorry, this m of 1 is 3, so that had to be a 3 there, not a -3. I did the derivative. M of 1 is 3. So therefore, when I calculate all this out, that's 6, 12. 12 minus 3 is 9. So that's going to give me 9 as the answer. Right. This is a classic problem, and I think I mentioned this before, of using just the functions like that and recognizing what the rules are. And again, it goes back to what I was saying previously, going through a lot of problems and identifying the rules within the problem. And sometimes it's a good idea to say which one is inside the other. So I might say in this one, it's a chain rule inside of a product rule, or it's a product rule inside of a chain rule, right? Something like that, as I'm going through all my problems. All right, given the graph of f of x above, right, which of the following is the graph of f prime of x? So the first thing I'm going to do is figure out the zeros. So I'm going to come over here, and the zeros are going to be here and here, about 1.5 and about negative point, I guess that would be 0.33. So 1.5, this one works. This one definitely doesn't work. And this one works. So I'm using the zeros. Then I'm going to look at the slopes of the derivative. So here, all the slopes are positive. F prime of x is greater than 0. All right. Here, f prime of x is less than 0. And then it's positive again on that side. So it has to be positive, negative, positive. So here I got positive up until that point. It's negative underneath the graph and then positive there. So it looks like the answer is going to be C for 7. All right, someone was mentioning also, how do I remember these things, right? Generally on the exam, next to this graph, they will have y equals f of x like that, or up in the top corner. One of the things you can do before you start the problem is circle it and mention it in your head, right? This is y equals f of x before you start your problem, so you don't mess it up. A lot of students, the problem says given f prime of x, and then they go over to the graph and they're thinking f of x. So before I start, I might circle that, right? The IB exam will probably always have them labeled with y equals f of x on the graph, so you can circle it, or y equals f prime of x. Okay, so here, given the graph of f prime of x here, and again, there would probably be an f prime of x, y equals f prime of x up there. So the first thing I might do is actually just circle it, right, before I start my problem. So this is f prime of x. So we got to work the other way around, right? I know that the one way you could think about it is this is a cubic, right? So we're going to have a quartic. So we can eliminate a right away because that's going in the other direction. And of course they're going to have a there because the person who reads the question and doesn't realize that this is f prime of x versus f of x, they'll get the answer a, which is not going to be correct. So the other thing I can see from this, I've eliminated a. And the other thing I can see is that these guys both have maximums and mins at the same points, right? So they're all there like that. And they're going to match up with these guys here. So the max and mins, oops, not there. We'll get to that one in a second. The max and mins are here, here, and here, and all of them line up on those points. So the max and mins really aren't going to help me. Right? We could do a couple of things. We could look at the second derivative. So the second derivative are going to be the max and mins of here, and they're going to be our points of inflection, right? But it looks like both of them, if I look at those guys, what do I mean by that? If I look at these points here, it's a max on f prime of x and a max over here, which means that that's going to change concavity somewhere about here and here. Notice they both change concavity there, here, and there, right? I could continue with this, but I might go with something a little bit different here. I'm going to use the first derivative, and I can see from over here, f prime of x is less than 0. So therefore, f of x must decrease. It must be going down. So the only graph that's going down to -1 is here. Notice that f of x is decreasing there. So it looks like the answer is going to be B for 8. And I could double check this with using another part of the graph. I could check with the second derivative and look for concavity. I could do all sorts of things, right? But I chose to go with this in this particular case, with just going with the first derivative. All right, and finally, number 9, the function f of x equals that passes through the point 1,4 and has gradient of 13 at that point. Now, the first thing that students try to do here is they just try to work something out without trying to figure out what they have, right? So I always tell students to organize their work, put their work together, figure out what they're going to do, and write it in as simplest as terms as possible. And what do I mean by that? This right here, what information does that give me? Before I do anything, I'm going to say that f of 1 is 4. I'm not going to do any work on that, right? I just want to write down in simplest terms what I have to do, not necessarily do the work to it. I like to prep all my thoughts before I jump into a problem so I don't miss anything. Now, the second piece of information that we have here is right here, this guy and that. So that tells me that f prime of 1 equals 13. So notice what I've done here is I've written down what I need to do or what the problem is telling me before I do any work whatsoever, right? To me, that makes more sense than just starting with one thing and then trying to work with it and then change direction and try to figure something out and then try to figure something else out. And the more complicated the problem is, the more lost you get because you haven't written out your basic stuff from the very beginning. So give that a go when you're problem solving, right? That you write out the basic stuff first without doing any work. So now I know that f of 1 is a plus b plus 1 is equal to 4. And I know f prime of 1 is 2a plus b, that 1 goes away, is equal to 13. So I can just subtract 1 from the other. So I'm going to subtract the bottom from the top. So if I do that, 2a minus a is a. And then b minus b is 0. 0 minus 1 is equal to 13 is equal to 9. Something's not right. Oh, sorry, it's 3a. Right? 3x squared, yeah, so it's 3a. So that's going to give me 2a. So a is going to be 5. And therefore, b is going to be what? 5 plus 1 is 6. B is going to be negative 2. And then I finish the problem. Okay? What you might want to have done right at the beginning here is just so you don't make that mistake that I made there, trying to do it all in your head, is just write that f prime of x equals 3ax squared plus b. And then the derivative of 0 is 1. So really straightforward. Okay. Now, the other thing you might want to start, as I mentioned this before, right? Right here, before I start anything, I have two unknowns. Which implies I need 2 equations. And then you have to say, well, where am I going to get those 2 equations? And then I put these guys together. Now, again, I don't write any of this stuff down, but this is going through my head. I have two equations. I need two unknowns. Okay, where I'm going to get them. I try to go in my problem and write down what my two equations are without doing any work. I'm not going to work on either one of them until I have both of them laid out what I need to do. And then I'll go and work on each one. It just helps me keep my problem organized. All right. I hope this video was helpful. Remember to practice your calculator on some of these problems as I showed you. And if you have any questions, contact your section teacher. See everyone later.